Alright, so this is our demo. The whole system running. And first thing we want to do is check out one of the previous runs and go over what to expect when we start seeing data coming in. So the profile is supposed to look like this. It's got 3 temperatures that we're trying to hit. First one at 140, second one at 170, third one at 215. These are all in degrees Celsius. We've got our ramp time controlled by our maximum pulse width, which we'll go into later. We've got a hold time of, wow, it's hard to draw a straight line. A hold time of 45 seconds here. A ramp time up to 170. That's not really defined. And once we hit 170, we've got another hold time of, well, of 45 seconds. And then we head up to 215 degrees C. And at 215, we've got a hold time of 60 seconds. This is really for the sake of example, so you can see it regulate. And this is where it's hardest to regulate. You can see between here we've got a little ripple. That's about plus or minus 5 degrees C, which really isn't too bad. In fact, it's better than I thought it would be. It took a little while to kind of tune this up so that was this smooth. There is one small artifact there, and that's mainly due to the sampling, plotting, and averaging. Every now and then you get a data point that's a little off, and then after 215 for 60 seconds, we shut down and cool off. And so this thermal profile is supposed to be a copy of this thermal profile, which is a solder paste thermal profile. And so that's what we're shooting for. And this run wasn't too bad. So hopefully the run we record now is that good or even a little better. So first, let's check out our system. And the first part is our electronics box, which is really the biggest part. In here we got the solid state relay, our terminal block, our screw down power terminal, our analog interface here, and our digital controller back here, the 2553 on a launch pad. So this is where you need to be careful. This is where your AC power is going to be coming in. This is earth, ground, neutral, and this is going to be your hotline that we pulse width modulate here with this solid state relay. So that's our power cable from the toaster. It's literally just tied into this, and then we've got this, which is our power cable plugged in over here to the wall outlet. So we'll turn on our AC power on this power switch. So now this is all live. And over here we've got 2 multimeters. This is showing the output voltage of the thermocouple. And there's a little bit of an output because this toaster hasn't cooled down totally from its last run. This is a room temperature, and we'll go into how this is all calculated later. And this mainly shows about 8 millivolts per degree C, and this shows 0.702, and you subtract a half a volt off that because of the offset from the MCP 9700, divide it by 10 because it's 10 millivolts per degree C. And we get about 20 degrees C in the toaster, and that's the toaster with our thermocouple in there. And so let's get started. So first thing we got to do is program our chip. So we'll program the MSP 430. And so our chip's programmed. We'll launch our GUI, and this is our GUI we use to communicate with the system. Open our serial port, which is the virtual serial port from the launch pad. It runs at 9600 BPS. And so now we'll turn our firmware on. You'll see it's reporting back room temperature and thermocouple temperature. So little off because it's a little warm in the toaster. It's about 18 degrees C in my room and about 20 degrees C in the toaster. And so now we're ready to go. We'll launch our plot window and click run. And run will start the thermal process. basically tells our microcontroller to go. And so now we just let it run, and it should run through its profile on its own. So some of the things going on here in the GUI, this is the start command that we send out to tell the microcontroller to start doing its thing. This is the data coming in to update our temperature fields. This is the data from the serial port, and we'll go over that in more detail in some of the other videos. This is our baud rate, 9600. This is our serial port, COM2. Open, close, serial port, run, starts the profile, and launch graph, launch our little plot window. This is the temperature inside the toaster, thermocouple temp, and this just keeps track of our room temperature. This is a software debugging window I usually use. And so you can see we're starting to heat up in the toaster, 50 degrees C, and you can see we're increasing in temperature here. We have a pretty steady ramp rate. Again, we'll go into how this is controlled later on in the embedded videos. You can see the thermocouple voltage output increasing pretty reliably. You can see that the room temperature is not changing that much. And on our toaster here, we've got the pulse width modulated power coming in, and in there you can see the thermocouple kind of in the middle, hanging out in the middle of the toaster to get a decent average temperature. Getting back to our plotting mechanism here, there's a little bit of noise in this run, but it's not too bad. Well, in the firmware, I've got it averaging 128 samples from the sensors before it sends out a data point to this. So I could probably up that, maybe smooth this out a little bit, but usually it runs a little smoother than this. And so the first temperature we're heading up to is 140 degrees C. We're going to be about this spot right here. Then we're going to hold for 45 seconds. And so you can't really see the coils heating up at this temperature because it's still a little cool, but once we get up towards 200, you can see them really glowing. I'll make sure to point that out. And you can probably hear the toaster kind of expanding as the metal heats up so fast. So the ramp rate's slow just to allow the parts to heat up and not induce a real big thermal shock to any of the components. And so this is the most time-consuming part, is letting this heat up. So we're about 20 degrees C away. Once we hit 140, you'll see this thing kind of throttle back and power down, and then hold that temperature for about 45 seconds. And you'll see it in here. It'll be pretty smooth. It doesn't really get rough until you get up above 200 degrees C. So we're almost there. So we'll hold on before we switch over to the hardware once this hits 140 or gets close. We're at about 136, 135. So now we'll go over to the hardware and see we're at about 1 volt on the thermocouple, and we're still pulse width modulating the toaster, and we're about to hit 140 right about now. And so you can see it's powered off to try to prevent some of the overshoot here. And once it comes back at 1 degrees over our hold temperature. And you see it's come back on. It's started to warm up a little bit to try to hold our temperature about 140, 141. It's powered back off. We've got about 1.042 volts on our sensor. And if we go back to the graph here, you can see it's pretty flat. So it held at about 141 to 142 for the last 45 seconds. And so now our time window, our hold time has expired, and we're going to head up to our next temperature, which is 170. And so this isn't too bad. This is pretty flat, and it's pretty easy to regulate at lower temperatures So it's pretty smooth. You can see it's going to start ramping up now and start heading up to 140. And you can also see over here on our system, the pulse width on the toaster is a little wider. You can see the light stays on a little longer. See the coils are getting a little hotter in there. And maybe you can see our thermocouple in there. You can see kind of in the middle where we're getting our temperature from, but these things are heating up a little more now as we're delivering more power to them. Our pulse width's a little wider. You see on our multimeters, our room temperature is the same, and our output from our thermocouple keeps increasing. We're about 1.2 volts, and so we're getting up there. Toaster's shut off. As you can see, we've hit 170, and then it turns back on to regulate around 170. About 171, 172, and it's going to hold here for 45 seconds. So I have a little dip and a couple little artifacts coming across from our micro that are getting plotted. But so once this 45-second time expires, we're going to head up to 215, which is what's happening right now. Well, almost. We're about to, okay, now we're heading up to 215, and this is where it really gets kind of interesting. You'll see this ramp rate increase quite a bit because our max pulse width is going to basically increase to 100%. The duty cycle here on this waveform is going to be about 100%. We've got full power on. This is getting pretty hot. You can see why I've got this lifted up on hammers, and it might make you a little nervous. Because this is a lot of power and a lot of heat. I can feel it just sitting over here. So you don't want to have anything around this. You know, you might start a fire. And if you look at the plot that we've got over here, our application is pretty steep. It increases pretty quick. And we're going to head up to 215 and then regulate at 215 for 60 seconds. You can see that our voltage output on the multimeter is about 1.6. You can see over here we've hit 215, and we're heading back down, basically shut off. But when we come back, we'll try to pulse width modulate this up and down by expanding and shrinking the duty cycle. You can see it's back on at 100% right now. And so over here, you can see we're trying to hold it about 215, and it's holding at about 216, 217. There's a little more ripple up here just because it's so much more power to control. We overshoot a little bit by about 5 degrees C. We're hitting 220. But again, for my application, that's okay. It's not a problem. We've got a little artifact here, and this a lot of times doesn't happen, but you know, depending on how our sampling and plotting goes, sometimes we get a couple of these. And so now our profile is over. We're going to start heading back down. And so if you leave it closed, it takes a while. But that's it. That's the whole profile. It's a little jumpy in this example, but not too bad. Most of this is sampling and averaging and data point issues. It's, you know, I'll put some pictures up of some other runs so you can kind of see a couple different runs and how it reacts. And you can see over here we've got our hold time, ramp up 170, hold time, ramp up to 215, holds between about 212 and 220. So it's not too bad. And now it powers down, it shuts down the digital controller, and we'll turn our AC power off just for safety. Open the door up on the toaster, and you can see the temperature really drop down real fast. Wow, that's hot. And that's it. So thanks for watching, and next couple of videos should go into some pretty good detail on how I got this built, what I did, and maybe it'll help some people out.